So we're going to move right into the lightnings, right? So the lightnings are short talks. The idea, unlike some of the longer ones, where you can sort of meander in and out, go down a rabbit hole, come back out. The lightnings is we want to talk about one thing and we want to get one point across. So you got to strap in and you got to pay attention. Don't blink. Now is not the time to walk away because the lightnings are fun and they're fast and exciting. And we're going to get started off with Yevgen Nebesov, who was born in Kharkiv and has been residing in Germany actually since 2004. Programming, team leadership, business analysis, software architecture, these are all things that Evgen is involved in. And he's been sort of spending time consulting with large German companies, railway, logistics, medical services, so on and so forth. The topic is socio-technical engineering. I guess the idea is to treat socio-technical systems as systems in the way that us technical people would think about them. So without further ado, take it away, Evgen.
Доброго дня, Ukraine. Welcome everyone. My name is Yevgen, and today I will be speaking about socio-technical engineering and how to engineer socio-technical systems like usual systems. I will briefly introduce myself. I work as a software architect. I live in a small city of Brusal in southern Germany. Originally, I am from Kharkiv, Ukraine, and I have experience in logistics, railway, and medical devices sectors. In my work as software architect, I've seen a lot of projects with separated roles of software architect dealing with business domain aspects and technical aspects, and the role of project manager dealing with operational, organizational, and political aspects. But a lot of people before me figured out the so-called social materiality principle, which says that people and artifacts are interconnected and have influence upon each other. For example, a coding convention as an artifact can nudge people to write code in a certain way. And this interconnectedness and influence means that it is not enough for doing systems architecture for systems architecture, and project management is not enough for doing project management. What we need is to treat social and technical aspects as a whole system and as in a holistic way. I call it this way as socio-technical engineering, but the question is how to achieve this. And here's a simple idea I want to share with you today, which says that if socio-technical systems are systems, then they can be engineered like other systems. And what we do in systems engineering, we basically write requirements for systems, we design them, and we troubleshoot them. And in this talk, I will guide you through these three areas of systems engineering applied to socio-technical systems. Let's start with requirements. So similar to software systems, we can write requirements for socio-technical systems. For example, requirement for development availability could say we want to be able to make any project decision without depending on any single person. How to achieve it is an implementation details, but we need any requirement if this property of the system is important for us. Another one is developer satisfaction. We can say we want our engineers to be motivated and fulfilled while working on the product. How to achieve it? Again, implementation details, but we need always requirements as a baseline to verify our design. Now, design. So what is system design is all about? System design is about making arrangement decision about systems elements. So if we know what our systems elements are and what are the arrangement decisions that shape them, then we can use tactics from other systems to solve structurally similar problems and requirements in socio-technical systems. So what are our systems elements in socio-technical systems? There are people, like person, Cassandra. There are tasks. Tasks address artifacts. For example, task addresses software architecture documentation or code. There are roles like software architect that can be allocated to people. We can say the role of software architect is allocated to Cassandra, and the roles are always responsibilities for artifacts. So the roles are not about doing something, the role is always about being responsible for something. Now, what are the arrangement decisions? They have decomposition decisions, how to take things apart, for example, how to split the system into system components, or how to split the project organization into teams. Now, when everything is splitted, the question is how to integrate it again so that the system can work. For example, we can connect to system components by middleware, or we can connect to teams by having Scrum of Scrum meetings. And there are allocation decisions about allocating one entity to another one. For example, we can say we allocate the role of lead architect to Cassandra. Now, having this language of elements and this arrangement decisions, we can look at the tactics that are used in other systems. For example, the design of Dragonfly is reused by designing helicopters. And the same idea is here, that instead of designing solutions from scratch, we can reuse in someone else's work for our requirements. Let's look at one example of achieving availability requirement we had before. We want to be able to make any architectural decision at any time. So what we can do is to look into different books, for example, Software Architecture in Practice, and there is a list for different tactics for different requirements. For example, for availability. There are a lot of them, we don't need all of them, we just can pick a couple of them as an inspiration for solving our particular problem. For example, we can pick tactics, self-test, and removal from service, and write Gherkin-style test cases like given lead software architect Cassandra is on location, when an external software architecture audit for the project is requested, then the audit should not result in any major findings. And this is a test case like we used to have for software systems. We can execute it for our socio-technical system, our project. And what we do is we remove Cassandra from service, we send her on vacation, we request software architecture audit, and we see if our system satisfies the availability requirement or not. Another tactic is redundant pair, which says that we don't allocate a service to one instance. In that case, we allocate the role as a service to two instances. They sync among each other, but every one of them can execute the role of lead architect if another one is on vacation. So that's it about design. Now let's look at troubleshooting for systems. And the main idea about troubleshooting is that bugs always relate to requirements. If there are no requirements, then there are no bugs. If someone perceives something as a bug, for example, someone says we are too slow, the question is, who said we should be faster? Maybe it works as designed. If someone says we have too many bugs, well, maybe it works as designed. If we want to have less bugs, we have to introduce new requirements to have our system be less error prone. Maybe we have to redesign our socio-technical system, and once we redesign it, we have to verify if the new design is compliant with other requirements. So we have to communicate the redesign and verify it again. So that's it basically, troubleshooting. And now let me conclude the talk. The basic idea was that it's not enough to have separated views on technical and social aspects. We need a holistic approach to treat social and technical aspects together. I call it socio-technical engineering. And the basic idea is that we can say that socio-technical systems are systems. We can write requirements for them, we can design them, we can test and troubleshoot them. That's it. If you want to learn more about socio-technical engineering, I will be very glad and happy if you can connect and exchange ideas. You can find me on LinkedIn or on my website, complexitynavigator.rocks. And that's it for today. Many thanks for your time, many thanks for your attention. Дякую everyone, and have a lovely day. Bye-bye.
Well, thank you so much for that talk. Again, if you're playing the DevOps Days bingo game at home, you now have the center square, which is socio-technical systems. Shout out to Deming.